Everyone and very good afternoon. So welcome back again to the second session of the chapter Measures of Dispersion. In last session, we have completed the topic range and mean deviation. So in today's class, we are going to discuss standard deviation and quartile deviation. So let's welcome you all guys. Akilam Deshwari is there, Anjali Verma, Anya Kumari, Shreya Tiwari, Arpi Shah, then Sonam Rajawat, Manisha Rajpurohit, Soumya Rajan, Surya Kumari, Natasha Chopra is there, Richa Kumari, Swati Giri, Pramod, Samina, Kevin, Dimple, Ravish Chaudhary, and Sabina. Great. So welcome guys. Very good afternoon. So let us begin with the session. So first of all, we are going to start with standard deviation. Now, standard deviation is one of the most important topic, not only from the exam point of view, but this is commonly used in many other subjects also. Like in financial management, we will be using this standard deviation. In economics, as well as in many other places, standard deviation is used. So let us start with the standard deviation. So what are the basic features of standard deviation? So standard deviation is denoted by a symbol. This is the symbol of standard deviation, and this symbol is known as sigma. This symbol is known as sigma. Also, it is known as neta. Alternatively, it is also known as neta. So you can say it sigma or you can say it neta. Now, there may be one question in your mind. If this is sigma, then what is this? So these two are known as sigma. Like, what is the difference between these two? Both are alphabets, both are A. But the first one is small a and second one is capital A. Same as here. First one is small sigma, which is used for standard deviation, and other one is capital sigma, which is used for total, or you can say sum. Okay, so capital sigma is used for sum, small sigma is used for standard deviation. So first of all, standard deviation is denoted by sigma, also known as neta. So this is most important measure of dispersion. Most important measure of dispersion, and having many useful properties. So it is the best measure of dispersion out of out of all four measure of dispersion. Standard deviation is the best. So like whenever we have to decide which measure should be used, so by default standard deviation is used in majority of places. Then if all observations are same, or before that, one more thing, all observations are used for calculation of standard deviation. So it is based on all observations. It is based on all the observations. Then the next thing is, if all observations are same, if all observations are same, then standard deviation is equal to 0. If all observations are same, then standard deviation will be 0. Let's say if all observations are 2, 2, 2, then their standard deviation will be 0. Simple point. And not only standard deviation, all kind of deviation will be 0 if all the observations are same, whether you find range, whether you find mean deviation, quartile deviation, or standard deviation. So here also, if all observations are same, then standard deviation is equal to 0. Then the next point is the square of standard deviation. The square of standard deviation is known as variance. Standard deviation का square उसको हम क्या बोलेंगे, वेरिएंस। Okay, so this is variance. So variance is denoted by sigma square, or you can say neta square. This is the square of standard deviation. Now, in case of two observations, so if we are having only two observations, then how can we find standard deviation? So there is a shortcut formula for that. So we can write, in case of two observations, standard deviation is equal to half of range. Standard deviation is equal to half of range. So what is range? It is highest value minus lowest value. And since we are doing half, so we have to write divide by 2. So h minus L upon 2. This is the formula for standard deviation. But this is applicable only in case of two observations and not more than that. All right. Okay. Now, in case of first n natural numbers, so in case there are n natural numbers, then how can we find? So there is one more shortcut formula for this. N natural numbers, then standard deviation will be root of n square minus 1 upon 12. Root of n square minus 1 upon 12. So in this way, we can calculate standard deviation of first n natural numbers. So let's take one example. If we have to find standard deviation of first 7 natural numbers, first 7 natural numbers, that means n is equal to 7. So what will be the standard deviation? It will be root of 7 square minus 1 upon 12. So what is 7 square? It is 49 minus 1 is 48. So 48 upon 12 is root of 4, which is 2. Which is 2. Okay. So standard deviation will be 2. And if we have to find out variance, if we require variance, then we will square the standard deviation. That is 2 square is 4. So 4 will become the standard deviation. Sorry, variance. 4 will become the variance. And 2 is known as standard deviation. Okay. So all these are the basic properties or characteristics related to standard deviation. So let us understand one more point. Standard deviation is always positive. Standard deviation is always positive. And not only standard deviation, all the measures of dispersion are always positive. Whether it is range, whether it is quartile deviation, mean deviation, or standard deviation. Any kind of measure of dispersion is there, it will always be positive. Okay. So any doubt till here, let me know. Otherwise, we can proceed with the other formulas. So let me take one example of two observations. So let's say we are having two observations. One is 10 and other is 30. Then how to find the standard deviation? So it is half of range. So highest value minus lowest value divided by 2. So standard deviation will be 10. This is the standard deviation. Okay. So Rishita says no doubt. Aditya Darshan says no doubt. Okay, great. Vaishnav is asking, मैंने अभी January से classes start की है. Then which type of calculator should I buy? See, Vaishnavi, you can buy a basic normal calculator, which is having all the functions, especially memory function. You must have memory function, that is M plus, M minus, MRC, and also GT button, that is gross total. So if all these basic things are there, that calculator you can buy. Okay. and always try to purchase a good quality calculator, because it is the only thing which will help you in examinations. Many times what students do is like they buy a very cheap calculator of rupees 100, 150, and in examination, if it falls from the table by mistake, each part gets like disconnected. So such kind of situation must not happen with you in examination. So always keep your calculator very, very of good quality. Like as you spend on your phone, on your mobile phone, you spend 20,000, 30,000. Some people spend 1 lakh. But on your calculator, at least you must spend 500-600 rupees to get the good one. Okay. Okay, so Bhumika says no doubt. Mahima is all clear. Manisha is clear. Manish is okay. Akhilandeshwari, no doubt. Perfect. So now let us move with the other formulas. So we can write the first method to calculate standard deviation in individual series. We are calculating standard deviation in individual series. So what is basically individual series? We have done individual series is the series which is having only variable. There is no frequency involved. So we can write the first formula, that is known as direct method or summation method. Direct method or summation method. So what is the formula? It is neta equal to root of sigma x square upon n minus sigma x upon n whole square. Sigma x square upon n minus sigma x upon n whole square. This is the first formula, which is known as direct method. The second formula is known as shortcut method. Second one is known as shortcut method. Now, in the shortcut method, what we have to do, we have to take assume mean. So the formula will change a bit. So we will write the formula as root sigma. In place of x, we will write dx. Sigma dx square upon n minus sigma dx upon n whole square. So in this shortcut method, what is dx? Dx means deviation. Deviation of x taken from assume mean. Deviation of x taken from assume mean. This is known as dx. Okay, this one is known as the shortcut method. And now the third one, let us write the third formula, that is known as, or we will be using step deviation method in continuous series. And now we will be using one more formula, which is using mean. That is, we can take deviation using mean. So formula will be root of sigma x minus x bar whole square upon n. Sigma x minus x bar whole square upon n. So these are the three formulas mainly used in individual series. Now let us take one example and solve all these questions. So let's say we are having the numbers as 10, 20 and 30. These are the figures. We can write a bit here. X is 10, 20 and then 30. Now, as per direct method, what is the requirement? The first requirement is sigma x. So we write total of all the observations. So what is the total here? It is 60. Then also we require x square. So it is 100, 400 and 900. The total comes 1400. The total is 1400. Now, applying the values in the formula, sigma x square is 1400 upon 3 minus 60 upon 3 whole square. So we have applied. Now let's solve. How much is coming? 1400 upon 3 minus, what is 60 by 3? 60 by 3 is 20 and 20 square is 400. Now you can take the LCM and get the result as 200 upon 3 and square root. So final answer is 8.16. After square root, you will get the result as 8.16. This is standard deviation. Okay. So don't forget to do the square root at last. So 8.16 is the answer using direct method. Now, if we take shortcut method, we have to find dx. That is x minus a we have to calculate. So for that, we have to assume any number as a. So let us assume 10. You can assume any number, 10, 20, 30, any number. So let us assume 10 as a and then solve. So what will be the dx now? Dx will be 10 minus 10, 0. 20 minus 10 will be 10 and 30 minus 10 is 20. So our dx is basically 30. Also we require dx square. So dx square is the requirement. So 0 square is 0, 10 square is 100 and 20 square is 400. So what will be the total? The total will be 500. The total is 500. Now applying the figures, 500 upon n. N is 3 minus sigma dx is 30 upon 3 whole square. Now let's simplify this. So we are getting 500 upon 3 minus 10 square is 100. After taking LCM, we are getting 200 by 3. So again the same answer, 8.16. So Manish Jain has got the answer. Mahima Jain has also got the answer, 8.16. Okay, so this is the answer using both the methods. Now let us try the third one. For third one, that is using mean, we have to calculate arithmetic mean first. So for that, let us calculate arithmetic mean, x bar. So x bar will be sigma x upon n, sum of all observation divided by number of observations. So sigma x is 60 upon n, n is 3. So it will be 20. X bar is 20. Now, as per this third formula, what we require is x minus x bar whole square. This is the requirement. So 10 minus 20 square, it will give us 100. Then 20 minus 20 square, it will be 0. Then 30 minus 20 square will be 100. So total will be 200. Total will be 200. Now let us put in the formula. So it will give us root of 200 upon n. N is 3. So directly we are getting the same answer, that is root of 200 by 3 or 8.16. 8.16. So this is the final result. All right. So all these are the formulas of standard deviation in individual series. So let's see some examples from the book. So we are having this example, 9th one. Let's solve this 9th example. 14.2.9. Find the standard deviation and coefficient of variation. Okay, so before solving this, let us write one more formula, that is the coefficient. So in range also, we have done the coefficient of range. So similarly, here we can do coefficient of standard deviation. So let us write coefficient of standard deviation, also known as coefficient of variation. So coefficient of standard deviation or coefficient of variation प्यार से हम कहेंगे CV. Okay, so in short we can say it as CV. So Mahima is asking what is the meaning of A. See, A here means assume mean, whatever we have taken the assumption, assume mean. So for taking the deviation, we assume any number as mean. Okay, all right, Mahima. So coefficient of variation or coefficient of standard deviation. So in short, we write CV. So what is the formula for this CV? It is standard deviation upon arithmetic mean multiplied by 100. So you can write neta upon x bar multiplied by 100. This is the formula for coefficient of variation. Now let's solve this. Ninth illustration, 5, 8, 9, 2, 6. These are the figures and we have to solve, we have to find standard deviation and the coefficient of variation. So both the things we require. So you can use any method, all of them will give you the same result. You can use any method. So as per the direct method, we require sigma x. So we can find the total. The total is coming 30. The total is 30. Then we require x square. So we can individually, we have to square. Do not square the total. 30 ka square nahi karna hai, it will become wrong. So you have to do square first and then sigma. So one by one, we will do the square. 5 square is 25, 8 square is 64, 9 square is 81, and so on. So you have to find the square and then do the addition. So sigma x square will be 210. 210 is sigma x square. Now applying the formula, root of sigma x square upon n, n is 5, minus sigma x upon n, that is 30 upon n whole square. So it will become how much? 30 by 5 is 6, 6 square is 36, and 36 into 5 is 180. So you can write 30 by 5, or it will be root of 6. So this is the value of standard deviation, that is root of 6. And when you calculate in decimal, it will give you the result 2.45. Okay. Now the second thing is to calculate CV. So for CV, it is standard deviation upon mean multiplied by 100. So standard deviation we have computed 2.45. Arithmetic mean is already we know it is 30 by 5. Because this 30 by 5 is simply sigma x upon n, which is the formula for x bar. So therefore, x bar we already have, that is 6. And then multiply by 100. So 40.83%, this is the coefficient of variation. This is the coefficient of variation. Okay. Now this 10th one property we have already covered. This property also we have covered. Yes, now it is the time for discrete and continuous series. So in case of discrete and continuous series, the formula will be a bit different. So let us write that also. Discrete and continuous series. So SD in discrete and continuous series. So for both of them, the formula will be same. So first we are writing again the direct method. So formula is similar to individual series, But here we have to insert frequency in between. Because in individual series there was no frequency, but here we have to insert frequency everywhere. All right. Swatigiri is asking AM means. AM means arithmetic mean, which we have done in central tendency chapter, arithmetic mean. Okay. Now, direct method we are writing, it will be root of sigma f into x square upon sigma f minus sigma fx upon sigma f whole square. This is the formula for direct method. Almost same, at every place we have inserted the frequency. The second formula we are writing is shortcut method. Now in the shortcut method, only change we have to do is replace x with dx. So in place of x, you will write dx. And what is the meaning of dx? It is same, x minus a, x minus assume mean. So standard deviation will be root of sigma f dx square upon sigma f minus sigma f dx upon sigma f whole square. This is the formula for shortcut method. Okay. Now let's write the third one. The third formula will be using mean. The third formula will be using mean. So we can write the standard deviation equal to root of sigma f into x minus x bar whole square divided by sigma f. So this is the formula for using mean. Okay, so these are the three formulas which we have to use. All right. Now the fourth formula is only for continuous series. So let's write that also here. That is known as step deviation method. Step deviation method. Now this formula is almost similar to the shortcut method. This is almost similar to the shortcut method. So let us write the formula for shortcut method first, and then we will do the changes. F dx square upon sigma f minus sigma f dx upon sigma f ka whole square. This is the formula for shortcut method. Now, what is the change we have to perform here? You have to put dash over dx. So you will write dx dash, here also dx dash, and at last multiply with I. At last multiply with I. So this becomes the step deviation method, and this dx dash can be computed as x minus a upon I. Or you can write dx upon I. So in this way we calculate dx dash. And what is I here? I means the class interval, the class width, or you can say the class size. This is the class interval. Okay. So now these are the fourth formula, and this fourth formula is for continuous series only. And remaining three can be used for discrete as well as continuous. So now the 12th one. The 12th one is having the continuous series. So find the standard deviation of the distribution. So class intervals are given and frequency is also given. So what is the first step? First step is to find out the mid value. So let's write this here. X. So first interval is 50 to 52. So what will be mid value? 50 plus 52 divided by 2. It will give us 102 upon 2. That is 51. Then 52 plus 54 upon 2. This will give us 53. Then next number will be 55. Then 57. And then 59. This is basically x. That is mid value. Then comes number of student, which is frequency. 17, 35, 28, 15, and then 5. We can add them to find the total. So let's add how much we are getting. 17 plus 35 is 52, plus 28 will give us 80, plus 95, and then 5 is 100. Yes. So total is 100. This is sigma f. Now, as per the formula, so which formula we can apply? You can use any method, any formula, all will give us the same result. So let us use the step deviation method. And for step deviation method, we have to take the assumption. You have to assume any number. So it is always better to assume the middle number. It's always better to assume the middle number. So if we assume 55, our calculation will become easy. So we have taken A as 55. Now we are finding dx. Okay. And basically we have to find dx dash here. So after that we will find dx dash also. So at present, if you see, what will be dx? So dx will be 51 minus 55. That is minus 4, minus 2, 0, 1, and then 2. And then 2. Okay, this is the dx. Now, according to the formula, what we require, if we are using the shortcut method, we require dx. No need of dx dash. So let us solve first using shortcut method only. So standard deviation will be root of, the formula is sigma f dx square. Now, as per this formula, the square is on dx. This square is not on f, square is only on dx. So how to calculate this? So first we will calculate f dx, and in next step we'll be calculating f dx square. Okay, so first we are multiplying f with dx. So 17 into minus 4, it will give us minus 68, then minus 70, 0, 15, and then 10. And now we can find out the total. So we will get the total here, f dx, and how much will be the total? 70 minus 25, it will become 45, and 45 is negative with negative 68. So it will give us 105 plus 8, 113. So 113 we are getting the total, and f dx square. So here for f dx square, multiply dx with f dx. Simply multiply. Okay, there is one error in between. Yes, we have done a small mistake here. We have to do some correction. It will be 2 and 4 here. So these will change. So let's change here. The difference will be 2 and difference will be 4 here. Yes. So now let us multiply again and get the result. It will be f dx 30 and this is 20. So the total will be how much? Minus 88. Now it's all right. So let's check. Now it's all right. So for f dx square, the square is on dx. So how to calculate? Multiply dx with f dx. So you will get f dx square. So minus 4 multiplied by minus 68. How much is there? it will be 272, then 140, 0, 60, and then 80. Okay. Now let's make the total. We are having how much? 472 plus 80. It will give us 552. Now we can put the values. This 552 upon sigma f. Sigma f is 100 minus sigma f dx minus 88 upon 100 whole square. Now you can simplify this and get the result. Okay. So in statistics, the main thing is the formula. If you remember the formula, you can do all kind of calculations associated with the formula. So the main thing is always focus on the formulas. You must learn all the formulas by heart. So Manish has given the answer 2.18. Anybody else? Yes, so 2.18 is the correct answer. So this is the standard deviation. Now Sonam Rajawat is asking, if I start now to study CA foundation, can I clear in first attempt? See, now we are still having like few months left: February, March, April, May, and almost June. So almost you are having 5 months in hand. So of course you are having a very good time to prepare. So if you are starting your studies now also, then also no worries. You can easily crack the exam in single attempt. Okay, so and also you have to follow all the tips and tricks which are required to learn the things, to remember the things, how to apply, what are the shortcuts, and all those things which we have discussed in our previous classes also. So everything you have to apply. So if you apply all those things, you can easily crack the exams. So Aditi Salvi has also given the answer. Reshita Kachwa has given. Great. So I think it is clear till now how to calculate the standard deviation. Then, now what will be the effect of change of origin and scale? So in the whole chapter, there is the same thing which we have done in the previous class also. Standard deviation does not get affected due to change of origin. But standard deviation gets affected due to change of scale. So change of scale का effect तो आएगा standard deviation पे, but change of origin का नहीं आएगा. So what was the meaning of change of origin? Origin means plus or minus. We are increasing a particular series by a number or decreasing the series by a particular number. अगर किसी भी series को add या less करते हैं एक particular number से, that is known as change of origin. Whereas change of scale में क्या करना पड़ता है? Multiply or divide. So standard deviation will get affected due to change of scale. Now, how to calculate this? So we had done in previous session also. There is a standard equation, that is y is equal to a plus bx. This is the standard equation. Now, in order to calculate the standard deviation of y, what we have to do? Mod b multiply by standard deviation of x. मॉड बी को आपको मल्टीप्लाई करना है, किससे करेंगे मल्टीप्लाई? स्टैंडर्ड डेविएशन ऑफ एक्स के साथ आपको मल्टीप्लाई करना है टू गेट योर रिजल्ट. ओके, सो लेट्स टेक वन सिंपल एग्जांपल. y is equal to 10 plus 2x and standard deviation of x is 4. What will be the standard deviation of y? So this you have to calculate. So it's very easy. First find out the mod of b. So it is 2 from the equation. So 2 multiplied by standard deviation of x is 4. So 2 multiplied by 4 gives us 8. This is standard deviation of y. All right. Okay, dear. Okay. So Manisha is asking, please repeat example number 12. Okay, all right. See, in example number 12, the given series is known as the continuous series. So what is the first step to solve? So whenever continuous series is given, the first step is to find out the mid value. So we have find out the mid value. Lower limit plus upper limit divided by 2. Then write the frequency as it is. Now you can use any of the formula which we have done. So here we have done with shortcut method. You can use direct method also, shortcut method also. It makes no difference. Result will be same. Okay. So after this, what we have done, what we have calculated is dx. That is deviation taken from assumed mean, and we had assumed 55. So dx will be x minus 55 we have done. So 51 minus 55 gives minus 4. 53 minus 55 gives minus 2, then 0, 2, and then 4. Now, as per formula, we required f dx and also f dx square. So we have computed this, applied all these figures in the formula, and got the result 2.18 kg. All right. Then Aditya is asking, standard deviation is absolute or relative. See, whenever we are talking about range, quartile deviation, mean deviation, and standard deviation, all these are absolute figures. But when you calculate their coefficients, if you calculate coefficient of range or coefficient of standard deviation, then it will be relative. Otherwise, it is only absolute. Now comes the next formula. Next formula is combined standard deviation. Combined standard deviation. So combined arithmetic mean we had done in central tendency. So similarly here we are doing combined standard deviation. So to find out this combined standard deviation, what we require is the number of observations in group 1 and group 2. Number of observations in group 1 and group 2. Then we require standard deviation 1 and standard deviation 2. Also x bar 1 and x bar 2, that is arithmetic mean. So all these figures are normally given to find out the combined standard deviation. So what is the formula for this combined standard deviation? So we write neta 1 2. 1 2 means it is combination of first and second group. So what is the formula? It is root of n1 neta 1 square plus n2 neta 2 square plus n1 d1 square plus n2 d2 square upon n1 plus n2. This is the formula for standard deviation 1 2. So all the figures will be given. We have to put here and get the result. Now what is this d1 and d2? d1 and d2 is basically the deviation. d1 and d2 is the deviation. किसका deviation है? It is x bar 1 minus x bar 1 2, and d2 is x bar 2 minus x bar 1 2. तो x bar 1 का deviation x bar 1 2 के साथ and x bar 2 का deviation भी x bar 1 2 के साथ में. So for this we have to calculate x bar 1 2 first. तो पहले हमें x bar 1 2 कैलकुलेट करना ही पड़ेगा. And how we can calculate, we have already discussed in the previous chapter. That was n1 x bar 1 plus n2 x bar 2 upon n1 plus n2. So all these are the overall steps. The first step is to calculate x bar 1, 2. In second step, we will be calculating d1, d2, and then the third step will be to put all the figures and get neta 1, 2. Okay. So these are the three steps for the calculation of combined standard deviation. And after doing all the three steps, you will get complete 1 mark. Yes. So this question is a bit lengthy, but yes, we have to do this because sometimes it can come in exam. So let's take some figures for this question. So we can try the 15th example first. So in this 15th example, what is given? For a group of 60 boys, the mean and standard deviation of stats are 45 and 2 respectively. So let us write them in a proper way. So there are 60 boys. So we can write N1 is equal to 60. The first group denote boys. So N1 is 60. Then we require mean. Mean is given. So x bar 1 is 45. Then standard deviation, neta 1, we can write it as 2. Now second group denote girls. So girls is N2. N2 is given how much? 40. Then mean. Their average marks are 55 and standard deviation is 3. Now what is the requirement? What is the mean and standard deviation of marks if the two groups are pulled together? If the two groups are pulled together, so the first step is to find the combined arithmetic mean x bar 1, 2. So for x bar 1, 2, it is n1 into x bar 1 plus n2 into x bar 2 divided by n1 plus n2. So from here we can get arithmetic mean. So how much it comes? 45 into 60. So 45 into 60 is how much? 2700 and plus 55 into 40. This gives us 2200 upon 100. So it will give us 49. So x bar 1, 2 is 49. Then in second step, we require D1, D2. So D1 is x bar 1 minus x bar 1, 2. It is minus 4. And then D2. D2 is 55 minus 49, which is 6. This is D1, D2. Now, at last, what we require is combined standard deviation. So put all the figures n1 neta 1 square. So 60 into neta 1 square is 2 square plus n2 neta 2 square plus n1 d1 square plus n2 d2 square upon n1 plus n2 is 100. Now you can simplify this on your calculator and get the result. So now come on everybody, you can solve this and give me the result. So let's see who gives the correct answer. So Shreya Tiwari has given 49 as combined arithmetic mean. Mahima Jain has also given 49 correct arithmetic mean. Okay. Bhumika says understood. Great. So here in this question, you have to be very quick into calculation because it requires more time. It is very difficult to solve this in 1 minute. So it requires normally 2 to 2.5 minutes. So you have to speed up in your calculations. So Rishita has given the answer 5.48. Shreya Tiwari has also given 5.48. Great. So 5.48 is the combined standard deviation. All right. Now, the next one is similar, 16th one. This I think you can try by yourself. So Mahima has given the answer. Bhumika Chauhan has also given the answer. Great. So this was basically combined standard deviation. Now, 16th one is similar. The question is given the mean salary, standard deviation of salary, and then number of employees. All these are given. The first part is asking to calculate combined mean salary and standard deviation of salary. This we can easily calculate. Okay. Now, what is the second point? What is the second question? Examine which factory has more consistent structure so far as satisfying its employees are concerned. Now, what is the thing here? We have to compare the two companies. We have to compare the salaries of two companies and which is more consistent structure so far. So here we have to do the consistency test. So there is one simple rule which we have to remember here for consistency. So whenever we are comparing two things, so always for comparison, you have to calculate coefficient of variation. Whenever we are comparing two series, two companies, two factories, two anything, then we have to use CV, that is coefficient of variation. तो हम क्या करेंगे, दोनों का CV find out करेंगे. We have to calculate coefficient of variation for both the factories, for both the companies. Now, जिसका CV ज्यादा होगा, if CV is more, this shows that the firm is having more variation, more fluctuation, more risk. If CV is more, it shows greater variation, greater fluctuation, more risk, and less consistency. It will be less consistent. Whereas, if CV is less, everything will become reverse. Variation will be less, fluctuation will be less, risk will be less, and it will be more consistent. It will be more consistent. Okay, so in this question, what is the requirement? We require more consistent. That means we have to find the factory which is having lower coefficient of variation. We have to find which factory is having lower coefficient of variation. So we can calculate coefficient of variation for factory A. So what is the formula? Standard deviation upon mean multiplied by 100. So 10 upon mean salary is 4800 and then multiply by 100. So here you can get 10 by 48. 10 by 48. It is how much? 0.21. 0.21, and then coefficient of variation for factory B. So it will be again standard deviation is 12, mean is 5000 multiplied by 100. So this time we are getting 0.24. So coefficient of variation for company A is less as compared to company B. Therefore, company A is more consistent in paying the salaries. So therefore, we have to select the first option, that is factory A will be selected. All right. So Bhumika Chauhan has given the correct answer. So factory A will be selected because factory A is more consistent in giving the salary. Now, before moving forward and before doing the tricky questions, let us try this 13th one. Okay. After that, we will be moving towards tough questions. So let's solve the 13th one first. If arithmetic mean and coefficient of variation of x are 10 and 40 respectively. So this 10 is what? This is arithmetic mean x bar. And what is this 40? This 40 is CV, coefficient of variation. And what we require is the variance of this one. So first of all, standard deviation is not given in the question. So we can calculate standard deviation using the formula for coefficient of variation. So let's apply that. Neta upon x bar multiplied by 100. So here we have to calculate standard deviation. So standard deviation upon x bar is 10 multiplied by 100 and CV is 40. So let's do some cancellations here. So from here we can get the standard deviation will be 4. The standard deviation is 4. Now you can calculate the other one. So y is equal to 15 minus 2x. This is the other equation. And from this equation, you can calculate the standard deviation. That is neta of y will be mod b multiplied by neta x. So what will be mod of b? It is 2 multiplied by neta x is 4. Therefore, we are getting 2 into 4 as 8. 2 into 4 will be 8. But if we require variance, then we have to do the square. So neta y square will be 64. So the 64 will be the correct answer. All right. So this is basically the variance. Okay. So now 14th one. Let's do one question number 14. After that, we will take a small break and then we will move towards tougher questions. So before that, let's try this 14th example. The 14th one says, compute the standard deviation without any more computation obtain the standard deviation of others. Okay, so 95862. So this calculation we have done above. This question, the same question we have covered above. Now, let us write this series here first. It is 9, 5, 8, 6, 2. Okay, this is the given series. And for this series, we have already computed standard deviation. It was 2.45. 2.45. Now the question is demanding that we have to calculate the standard deviation of this other series, but without applying any formula, without any other calculation. We have to find out the standard deviation. So how we can do that? So there is one connection between these two series. So what is the connection between the two series? We have to find that. So how to find the connection? See, here it is 9 and minus 1. How much is the gap? Gap is of 10. 5 and minus 5, again gap of 10. 8 and negative 2, again gap of 10. So in each and every pair, we can find a gap of 10. So we can convert this into simple equation. So we can write y is equal to x minus 10. So if you reduce 10 from x, you get y. 9 minus 10 will give you minus 1. 5 minus 10 gives you minus 5 and so on. So from this we have formed an equation y is equal to x minus 10. So if we have to calculate the standard deviation of y, we know already the formula mod of b multiplied by standard deviation of x. So from here, what is mod of b? What is the coefficient of x? It is simply 1. So we can write 1 multiplied by 2.45. So standard deviation is same 2.45. 2.45. Now let's take another series. This time the value of y is 90, 50, 80, 60, and then 20. So 9 and 90, what is the connection? 5 and 50, what is the connection? Simply, it is multiplied by 10. Multiply by 10. So we can write y is equal to 10x. Nothing to add or subtract. It is simply y equal to 10x. So let's simplify this. Neta y is equal to mod b. Mod b is 10 multiplied by standard deviation of x. It is 2.45. So the result will be 24.5. This is the standard deviation which we are getting. Okay. So Aditya has given the answer. Manish Jain has also given the answer. Rishita has given. Great. Now, third one you can try first and then I will give the answer. So you have to try what equation will be formed. It is 23, 15, 21, 17, 9. So this is a bit tricky one. Not that easy, but yes, you can find the equation. So what is the connection? You have to find the connection between x and this y. 9 and 23, 5 and 15, 8 and 21, and so on. So what is the connection? Shreya Tiwari says remain unaffected due to change of origin, but it is not exactly the change of origin. If you see the difference is not same. 9 plus 14 gives 23, 5 plus 10 gives 15, 8 plus 15 gives 21. So only you cannot say that it is addition or subtraction. So it can be combination of two things. That is, it can be multiply plus addition, multiply and division. It can be a combination also. So what is the combination? If you multiply x with 2 and add 5, you will get y. What we are writing? Multiply x with 2, add 5, you will get y. So 9 multiplied by 2 is 18, plus 5 will give you 23. 5 multiplied by 2 is 10, plus 5 will give you 15. 8 into 2 is 16, and plus 5 will give you 21. So in this way, you can see that this is the correct relationship between the two. So hence, you will find neta y as mod of b, that is 2, multiplied by 2.45. So the correct answer is 4.95. 4.95. All right. So this is your final answer. 4.95. So 4.90 you can write, yeah. So before moving towards the next question, let's take a small break of 5 minutes and then we will be continuing with the tough question and also the quartile deviation. All right. So welcome back, guys. Now we'll begin with example number 17. So 17 is a bit of tricky question, lengthy question. Let's do this. A student computes arithmetic mean and standard deviation for a set of 100 observations as 50 and 5 respectively. So here, what is given? There are 100 observations and 50 is the arithmetic mean and 5 is the standard deviation. So later on, she discovered that she has made a mistake in taking one observation as 60 instead of 40. Now, this is a correction based question. So, what is the mistake she has done? She has taken one observation as 60 instead of 50. That means 50 was the correct value and 60 is the incorrect value. So, we have to do the correction here. And what would be the correct mean and standard deviation if the wrong observation is left out or the wrong observation is replaced with the correct one? So let's try the first one first. So we are having n 100, x bar 50 and standard deviation as 5. So the first step is to calculate the correct arithmetic mean. To correct arithmetic mean, so x bar is equal to sigma x upon n. So what is x bar here? 50. Sigma x we don't know, and what is n? N is 100. So from here we can get that sigma x is 5000. Sigma x is 5000. Now we have to do the correction here. So as per the first part, we have to left out the wrong observation. So the correct sigma x will be 5000 minus, remove the left out, that is remove the 60 from here, you will get 4940. This is correct sigma x. Now you have to find out correct x bar. So correct x bar will be 4940 divided by 49. So divided by 99 because number of observations will now reduce by 1. So 100 minus 1, it becomes 99. So now you can check what is the result after dividing. So after dividing, you are getting how much? It is 49.90. 49.90. This is the correct x bar. Now we have to find correct standard deviation. So the formula for a standard deviation is root sigma x square upon n minus x bar whole square. But actually we don't know sigma x square. So we have to calculate sigma x square also here. So let's write the old figure first. We are writing the old figure first. Why we are writing old figures? In order to calculate sigma x square. So what is old neta x? Old neta x is 5. Then sigma x square is unknown upon n. What is n? Number of observations. Number of observations were 100 minus sigma x upon n, or you can write x bar. So x bar was 50. 50 square. Now you can simplify this and see what is the correct result you are getting. So squaring both sides, root will get removed. So sigma x square minus 250000 upon 100. On simplifying, we are getting sigma x square is equal to 2,52,500. This is the old one. This is the old figure. Now we have to do the correction. So correct sigma x square. So correct sigma x square will be 252 500 minus. So we have to remove the incorrect observation. So what was the incorrect observation? It was 60. So only we don't have to just remove 60. We have to do square of 60 and then remove. So 2,52,500 minus 3600. So how much we are getting now? This will be the correct standard deviation, correct sigma x square. So 2,48,900. This is correct sigma x square. Now you can apply this and find the result. So standard deviation will be 248,900 upon, this time n will be 99. Now you have to take n as 99 instead of 100 minus, this time also you have to write correct x bar. So correct x bar was how much? 49.9. 49.9. This was the correct x bar. Now you can simplify this and get correct standard deviation. So Manish is asking, wrong to remove किया 5000 में से तो old to add करेंगे या नहीं? See, in the first part, the question is saying only to remove. So there is no replacement. But in second part, we have to remove the old one and add the new one. So addition will be done in the second portion, but in the first part of the question, we simply have to remove the wrong figure. So after simplifying this, you will get your final answer. So Mehak is asking why we have written 99 here. See, number of observations has become 99 now. Earlier, there were 100 observations. Out of those 100 observations, there was one observation 50. But in place of 50, we have written by mistake 60. Now, question is asking us to remove this wrong value. So if we are removing this one number, so how many numbers are left now? So only 99 numbers are left. So therefore, we will divide by 99. So sigma x square upon 99 minus x bar whole square. So final answer which we are getting is 4.91. So Mahima and Shreya has given the answer. So 4.91 is the final result. So this is basically the first part. Now what correction should be made for? Same question is there, but what we have to do, add the correct one. So for sigma x, we have to add 50 here. So the figure will be changed. It will become 4990. This will get changed. And overall, the number of observations will be 100. Okay. And then for correction of sigma x square, we will subtract 60 square and add 50 square. So this will be added. So here we will be getting how much? 251,100. 251,400. So it will give us almost the same answer, but yes, the calculation will be a bit different. All right. So this was overall the standard deviation. So any doubts still here? when we have to start the quartile deviation. So we will be doing few questions on quartile deviation, and after that there are one or two lengthy questions. Then we will be discussing some questions from the exercise. Okay. So let us begin with the quartile deviation. So another measure of dispersion is the quartile deviation, or also known as semi-interquartile range. Semi-interquartile range. So what is the formula for quartile deviation? The formula for quartile deviation is Q3 minus Q1 upon 2. So third quartile minus first quartile divided by 2. And then there is coefficient of quartile deviation. Coefficient is Q3 minus Q1 upon Q3 plus Q1 multiplied by 100. So this is the formula for coefficient of quartile deviation. So these two things are required for quartile. So let us try this one. Example number 18. So quartile is a positional value. We already know this, and how to calculate quartiles we have covered in the previous chapter, that is measures of central tendency. So the first step is to arrange the series in ascending order. So we are given the data for 10 students. Marks for 10 students are given. So the first step is to arrange them in ascending order. So here we have arranged them. So for the calculation of Q1, we have to find out the rank of Q1. So rank of Q1 will be n plus 1 by 4. So 10 plus 1 by 4 will give us 2.75 rank. So here the rank is in decimal. Rank is in decimal. So how to find the Q1? We have to do the basic calculation. Second value plus 0.75 multiplied by, now 2.75 comes in between the third rank and second rank. So third minus second. So second observation is 42 plus 0.75. Third observation is 48 minus 42. So let's get the result, 46.5. This is Q1. This is first quartile. All right. This is first quartile. Similarly, we can calculate third quartile also. That is Q3. So 3 multiplied by n plus 1 by 4. So the rank will be how much? So you can directly multiply 2.75 with 3. You will get 8.25 as the rank. Now with the help of this rank, we can calculate the third quartile. So 8th plus 0.25 into 9th minus 8th. So what is the 8th figure? It is 65 plus 0.25, then 9th minus 8th. So 75 minus 65. So how much? It will be 67.50. This is Q3. This is third quartile. All right. Now, after these two calculations, what we have to do? Quartile deviation we can calculate. So Q3 minus Q1 upon 2. So 21 by 2 gives us 10.5. So 10.5 is the quartile deviation. Also, we can calculate the coefficient of quartile deviation. So what is the coefficient? Q3 minus Q1 upon Q3 plus Q1, and then multiply by 100. So after solving this, we get 18.42. This is basically the coefficient of quartile deviation. So it's very easy to calculate. The only thing is you must have knowledge of quartiles, which we have done in the previous chapter. So this is again equation based question, that is change of origin and scale. If the quartile deviation of x is 6, quartile deviation is given, and this is the given equation. So what is the quartile deviation of y? So we have to find quartile deviation of y. So the formula will be mod b multiplied by quartile deviation of x. So here the equation is not arranged. So we can arrange in our format. 6y is equal to 20 minus 3x. So y equal to 20 by 6 minus 3 by 6x. So 3 by 6 is basically half. So half multiplied by 6 gives us 3. So this is the quartile deviation of y. So in this way, we can easily calculate the quartile deviation. Now, one more thing is application of quartile deviation. So where quartile deviation is used. So when the series is open-ended, when the class interval is open-ended, then we use quartile deviation, because quartile deviation is simply based on middle 50% of observations. So let's say all these are the figures. In between is median, that is second quartile. Here comes first quartile, and this is third quartile. Now for calculation of quartile deviation, we simply require Q3 minus Q1. We do not require any figure which is less than Q1. All these are not required. And any figure which is more than Q3 is also not required. So that is why if the class interval is open-ended, so it will be open from the beginning or it will be open at the end. So it will make no difference in the calculation of quartile deviation. So therefore, whenever a theoretical question is asked, like if class interval is open-ended, which measure is best? The answer will be quartile deviation is the best measure. Okay, and why so? Because it is based on only 50% of observations, or you can say middle 50% of observations, whereas mean deviation is based on all observations. Standard deviation is also based on all the observations. So therefore, for open-ended class interval, quartile deviation is the best. So now for solving this, we have to find out the quartiles first. So let's understand this from book only. Given class interval and then wages. So this is the thing which we don't know, that is the class interval. Remaining all the figures are available, like the number of workers. We have find out the cumulative frequency for that. This is CF, cumulative frequency. Now for the quartiles, the formula is same, which is for median. For Q1 it is L plus rank. Rank is n by 4 minus C upon F into I. L plus n by 4 minus C upon F into I. This is the formula for quartile Q1. And in case you want to find Q3, then it will be L plus 3n by 4 minus C upon F into I. This is the formula. Now for the Q1, you require rank. So what will be the rank of Q1 in continuous series? So in continuous series, we use n by 4. Plus 1 is not used in continuous series. So what is n? N was 40, or how much? Yes, 40. So 40 divided by 4 is 10. So 10 is covered in which interval? So 10 will be covered in the second interval. 10 will be covered in the second interval. So this interval, this means it is 20 to 40. It is 20 to 40. So the lower limit will be 20 to 40. Lower limit will be 20. Frequency is 11. Then what will be C? C is just above CF. So C will be 5. So now we can put the figures. Lower limit plus rank minus C upon F. What is F? F is 11 into I. That is class interval. It is 20. So we are getting how much? 29.09. This is first quartile. And similarly, we can calculate third quartile also, which is coming 30. So after this calculation, the formula is the same for quartile deviation, Q3 minus Q1 upon 2. So 60 minus 29.09 upon 2 will give you 15.46 as the quartile deviation. So whether it is individual, discrete or continuous, the formula for quartile deviation will remain same. So now let's discuss this 21st example and then we will move further. The mean and variance of 5 observations are 4.8 and 6.16 respectively. So 5 observations are there. It is 5 is n, 4.8 is mean, which is x bar, 6.16 is variance, so we can write neta square. 3 observations are given, 2, 3 and 6. Remaining 2 observations we don't know. So we can assume the remaining 2 observations as A and B. So since mean is given, so we can apply the formula for mean. So we have applied x bar equal to sigma x upon n. So add all the observations and divide it by the number of observations. So 2 plus 3 plus 6 plus A and plus B. So add all these, divide by number of observations, which is 5. And then it is equal to the given mean, which is 4.8. On simplifying this, we get an equation A plus B is equal to 13. A plus B is equal to 13. This is the first equation. Now also we can use the second formula, which is for standard deviation. The formula is again the same, root sigma x square upon n minus x bar whole square, and to make it variance we have to square both the sides. So we can write here 6.16 and root will get removed because we have done squaring both sides. Sigma x square, to square of all the numbers, 2 square, 3 square, 6 square, A square, B square upon 5 minus x bar. X bar square, x bar is how much? 4.80. So 4.8 square. Now we can simplify this and form the equation. So on simplifying this, we are getting the equation A square plus B square equal to 97. On simplifying, we will get this equation. So we are having the first equation and this is now the second equation. So by solving 1 and 2, you will get the answer. But in exam, you don't have to solve them further. Simply use the option and find the answer. So let's say you are having the option as 6 and 7, then 10 and 3, 9 and 4, and then D option is none of these. So you have to check which option is satisfying both the equation. So 6 plus 7, 13. First condition satisfied. Second condition, 6 square plus 7 is square. It should be 97, but on adding we are getting only 85. So it is incorrect. Second, 100, 10 square is 100 plus 3 square 9 gives 109. It is also incorrect. Third one, 9 plus 4, 13 is there, and 9 square is 81, 4 square is 16, it is 97. So both the equations are satisfied. Therefore, C option is correct. C option is correct. Okay. So now all these are simple now. These can be done easily. Let's come on set A of the exercise. Some of the theoretical questions. Ninth, page number 14.56, you can take out. Question number 9. Which measure is based on the central 50% of observation? That is middle 50% of observation. So we have done just now, it is quartile deviation. Which measure of dispersion is based on all the observations? So mean deviation is there, standard deviation is there, but quartile deviation is not there. So option number D, which says A and B but not C. Appropriate measure of dispersion for open-ended classification. So when it is open-ended, then we use quartile deviation. This also we have done now. Most commonly used measure of dispersion, सबसे ज्यादा काम आने वाला कौन सा है? It is standard deviation, which has some desirable mathematical properties. जिस जो सबसे best है, which is having the best properties, it is standard deviation. Standard deviation. Now 14. If profit of a company remained the same for last 10 months, then standard deviation of profit for these 10 months would be. So you have to find out the standard deviation of profit. So the profit is same in each and every month. So we have discuss that when all the observations are same, then standard deviation will be 0. So option number C. Which measure of dispersion is considered for finding a pooled measure? Pooled means it is combined measure of dispersion, and combined is calculated only for standard deviation. Okay. 16. A shift of origin has no impact on. तो change of origin किसको affect नहीं करता है? किसी को भी affect नहीं करता. Neither range nor mean deviation and nor standard deviation. So option is D, all of these and quartile deviation. So all these does not get affected. Okay. Now 18. Number 10 and 16. There are two numbers only in the series and they are getting repeated equal number of times. So we have done when there are only two numbers, the standard deviation is half of range. So 16 minus 10 upon 2, it will give us 3. 19. For any two numbers, standard deviation is option B, half of range. 20. If all the observations are increased by 10, then the standard deviation would be increased by 10 or not? No, because change of origin has no impact on measures of dispersion. So option number D will be there. All these three remain unchanged. Because observations are increased by 10, it will not affect measures of dispersion. 21. If all observations are multiplied by 2, so this time it is change of scale, multiplication by 2. So whenever it is change of scale, it will affect the measures of dispersion. So result will be new standard deviation will also be multiplied by 2. Option number A. Okay. So this we have done. Then yes, the 12th one. You have to try the 12th one now. After that, I will answer you. So everybody, try this question number 12. If the mean and standard deviation of x are a and b respectively, then find out the standard deviation of x minus a by b. Come on, you can try this. And this is simple. Come on, everybody. So we are having Mahima, Swati, Shreya, Samina to give the answer. Manish is also there. Narendra, Shreya, Rishita. All these are active participants who can give the answer. Come on. So question number 12. X minus a by b. Find the standard deviation. So how you will find? So till now, no one has given the answer. Yes, Swati has given B option. Shreya has also given B option. That is 1. Okay. So girls' power is there. 2 as girls. Swati and Shreya has given the answer B option. That is 1. So let's discuss now. The given equation is y equal to x minus a upon b. If you want, you can write b separately also, or you can write common also. So accordingly, if we have to calculate the standard deviation of y, the formula is mod b into standard deviation of x. So what is mod b from here? So what is the coefficient of x? It is 1 by b. 1 by b. And what is standard deviation of x? So standard deviation is b. So 1 by b multiply b. B and b will get cancelled. Answer is 1. Samina has given D. D is incorrect. Aisha has given option B. Manisha Rohit has also given B. Yes. So correct is the B answer. Okay. So let's try one more question, 14th one. So now we have to answer question number 14. So let's see who gives the correct answer now. Standard deviation of x is 3, and what is the variance of 5 minus 2x? Variance of 5 minus 2x. Variance is required. Narendra has given option A. Ms. Khan Mujahid has given option number C, that is 1. Okay, so 2 different answers we are getting. One is A, other one is C. Let's wait for some more answers. So the given equation is basically y equal to 5 minus 2x. This is the given equation. Now, if we have to calculate the standard deviation of y, it will be mod b, that is 2, into standard deviation of x, which is 3. It gives 6. So neta y is 6. But we don't require standard deviation. We require variance. Therefore, we will square both the sides. So neta y square is equal to 6 square. So it will give 36. So correct option is 36. So Aisha has given option A 36. Suchian has given B option. B is not correct. Swati has given B, not correct. Samina has given B, but Aisha Sood, Shreya Tiwari, Swati Giri has given option number A. Pramod Kumar has also given option A. Alpisha is also correct. Option number A. Yes. So whenever the question is talking about variance, you have to be extra careful. Extra careful whenever variance is given. Okay. So 36 is the result. Now let's try one more. 15th one. Question number 15. X and y are related by 2x plus 3y plus 4 equal to 0. Standard deviation of x is 6. Find out the standard deviation of y. So SD of y you have to calculate. Very easy. Arrange first and then give the answer. Arrange and give. Mehak Roy has given option number B, that is 4. Let's wait for some more. Mehak, option number B. So first of all, you have to arrange. Shreya Tiwari has also given B. Samina also B. Yes. So the girls are correct. 3y is equal to minus 4 minus 2x. So y is minus 4 by 3 minus 2 by 3x. So standard deviation of y is mod b multiplied by standard deviation of x. On cancellation, you will get 4. So option number B is correct. Right? Now the next one is 16. Very easy question. The quartiles of a variable are given and you have to find out the quartile deviation. So whenever the quartiles are given, that means these are Q1, Q2, Q3, and you have to find quartile deviation. So Q3 65 minus Q1 45 upon 2. The answer will be 10. Option number A. So 10 is the quartile deviation. Now let's solve 18th one. So this time you guys have to answer question number 18. If the standard deviation of first n natural numbers is 2, then find out the value of n. N you have to calculate. So standard deviation of first n natural number is given 2 and you have to find out the value of n. Come on everybody. Who is correct? So Swati has given option number B. Okay. Swati is there with B option. So we are having students from all around the country. Western region Swati, southern region Pramod, Central region, Ms. Khan. Eastern region, Sochian. Great. So B option is given by Samina. Samina says option B 7. Swati also says option B 7. Right. So for the first n natural numbers, we have done one formula, that is root n square minus 1 upon 12. So what is standard deviation? It is 2. Then root of n square minus 1 by 12. So on squaring both sides, so root will get removed, and here we will write square. On cross multiplication, 48 plus 1 is equal to n square. So from here we will get n as 7. Number of observations will be 7. Option number B is correct. So Surya Kumari has given option A, but A is incorrect answer. Correct will be option number B, 7. Now, the next one, 19. X and Y are related by this equation. The standard deviation and arithmetic mean of X are known to be 5 and 10 respectively. Then what is the coefficient of variation? So here we have to simply calculate the coefficient of variation. The formula is easy. Standard deviation upon mean multiplied by 100. Standard deviation upon mean multiplied by 100. So come on, try everyone and get the answer. So in this case, we have to find out the coefficient of variation of series Y. So for Y, we require the standard deviation of Y upon arithmetic mean of Y multiplied by 100. So for standard deviation of Y, it will be mod B into neta X. So mod B is how much? 2. Neta X is 5. So it becomes 10. Whereas for arithmetic mean, you have to simply substitute the value in the given equation. So arithmetic mean of X is 10, and you have to find out the arithmetic mean of Y. So simply substitute the value in this equation. So Y equal to 2 into 10 plus 5. 2 into 10 plus 5. And then multiply by 100. So we are getting 10 by 25 into 100. Result will be 40%. This is coefficient of variation. This is coefficient of variation. Option number C. So Swati has given option number C. Okay. Now all other are the practice questions which you can try, and in case of doubt you can easily connect us and ask all your doubts on the application Students Clinic, or even you can ask in the next session whenever we get time. Okay. So at last, let us summarize it very quickly. It is basically a simple theory which we can summarize in few paragraphs. So first is, all these merits of standard deviation make standard deviation as the most widely and commonly used. तो सबसे ज्यादा काम आने वाला measure of dispersion is standard deviation. So it is most widely and commonly used. Now, if it is asked which is the quickest to compute, which measure of dispersion is quickest to compute, answer will be range, because we will simply do highest minus lowest. The quickest will be range. Where is the application of range? It is used in statistical quality control. जहां पर quality को हमें control करना है, वहां range का use होगा. However, range is based on only two observations. सिर्फ दो ही observation पर based होगा. Therefore, it will get affected due to presence of extreme observation. तो extreme observation का range पे सबसे ज्यादा effect पड़ता है. Then mean deviation is rigidly defined because on all the observation, it is based on all the observations and not much affected by sampling fluctuation. सो मीन को जो है कैलकुलेट करने के लिए सारे ऑब्जर्वेशन हमें यूज लेने हैं. सो इट इज बिट ऑफ डिफिकल्ट बिकॉज इट रिक्वायर्स लॉट ऑफ लेबर, लॉट ऑफ टाइम इज रिक्वायर्ड. And if we talk about standard deviation, then standard deviation is having more properties as compared to mean deviation. So therefore, standard deviation is more used as compared to any other measure. Then quartile deviation is also rigidly defined. It is easy to compute and also not much affected due to sampling fluctuation. So it is less affected or least affected, or we can say it is not affected by extreme observations because quartile deviation is based on middle 50% observations. Therefore, extreme observations will not affect quartile deviation. So, but it is not based on all the observation, so it has not the desirable mathematical properties. But this is best only for open-ended classification. When the class interval is open, then we can say that this is the better measure of dispersion. Right? So, finally, we have completed the chapter measures of dispersion. So, in statistics, you guys have completed the three topics: statistical description of data, then measure of central tendency, measures of dispersion. In the next class, I think there will be the topic of probability and then probability distribution. So 1 month is getting completed now for the new year. So you can imagine 2023 went very, very fast. आज एक महीना पूरा कंप्लीट हो चुका है 2023 को, और जो भी आपने गोल्स बनाए थे, whatever goals you had made, you have to remember them, recall them, whether you are able to achieve all your goals in this 1 month or not. So आज फिर से अपने गोल्स की डायरी को आप लेकर के बैठे, देखें उसको कि जो आपने न्यू ईयर रेजोल्यूशन लिया था उसको आप कितना कंप्लीट कर पाए हो. अगर आप उसको कंप्लीट नहीं कर पाए हो, सो वेयर यू हैव लेफ्ट आउट, कहां आपने उसको छोड़ दिया है, व्हाट आर द रीजंस, व्हाट आर द नेगेटिव पॉइंट्स, उसको लिखें एक बार एंड देन अगेन स्टार्ट फ्रॉम टुमारो. तो आज सारी कैलकुलेशन करें, again have a new start from tomorrow because still 11 months are left for this year and you have to make this year super duper fantastic for you guys. Okay, because you are having state foundation exam in June end, so a lot of time is there. You can put all your efforts and you can score very, very good marks. All right, so I hope you will do this task today and write all your desirable goals today itself based on the wall in front of you, so that every time you can see all your goals and get excited to achieve that goals. If you are not excited towards that goal, then it is not actually your goal. It is simply attraction, but it is not a goal. So goal is that thing which excites you, जो आपको सोने नहीं देता, जो उसके लिए efforts करने पर मजबूर कर देता है. Okay, so think over it. So till then, bye everybody, take care and see you in the next session.